Managing an amateur basketball league means coordinating a massive logistical operation with dozens of moving parts. Every city has a team. Every team requires a minimum of 9 players and a maximum of 12. You have up to 3 distinct coaching roles per team: offensive, defensive, and physical training, and everyone plays 2 games against every other team. Tracking those rules on a massive spreadsheet leads to immediate failure. You enter the same coach's name a dozen times, spell it differently twice, and your system generates irreconcilable errors. Complexity scales because different people need the data for different reasons. A coach wants to review individual player stats, while an accountant only cares about the ticket sales generated by the games. To organize this, you need a data model. It acts as an architectural blueprint, translating complex real-world structures into a format that different users can actually navigate. The solution we use today, the relational model, was developed by IBM's E.F. Codd in 1970. His logic worked, but early computers lacked the processing power to run his complex models efficiently. Modern hardware handles the load easily. Mastering how to translate messy, physical constraints into this highly structured digital format is the requirement for how modern software functions. The translation process starts with business rules. These are the specific, non-negotiable policies of an organization, like requiring exactly 30 credits per academic year or capping a roster at 12 players. These policies dictate our digital building blocks. We convert real-world concepts into abstract entities and then organize them into a simple 2-dimensional structure, a table. The table anatomy is strictly defined. Every horizontal row represents a single, unique object or person in the system. The vertical columns represent the specific attributes that belong to that person. All values in a column must follow the exact same data format. To keep everything organized, every table requires a primary key. This is a mandatory attribute, or a combination of attributes, that uniquely identifies every single row. Because a primary key is the sole identifier for a record, it cannot contain a null or missing value. If an entity doesn't have a distinct identity, it cannot exist in a relational system. Most organizations rely on data spread across multiple tables. If an insurance company needs to match a customer to their assigned sales agent, they have to bridge 2 separate datasets. If you duplicate the agent's full profile, their name, phone number, and office, onto every single customer's row, you create massive data redundancy. The correct solution is controlled redundancy. This is a table labeled agent. It stores the sales team's data, and you can see its specific primary key on the far left, the agent code. Looking at the customer table below it, you see the customer's attributes stored completely separate from the agent's personal details. But notice the bold black line. We intentionally duplicate just the agent code primary key, dropping it into the customer table as a foreign key to create a bridge between the two. This specific, controlled sharing of a single attribute allows tables to communicate. It links isolated grids of data into a cohesive relational network. Mapping multiple entities creates an entity relationship diagram, visualizing exactly how tables interact. It builds a human logical environment. By placing specific verbs on connecting lines, like a student enrolls in a class, designers can read complex constraints like natural language. While humans use this simple visual map to design the system, the database management system handles the heavy lifting, running all the structural complexity invisibly in the background. This chart tracks data model evolution. Early 1960s, hierarchical and network models were rigid. The 1970 relational model separated conceptual logic from physical storage, freeing designers from hardware complexity. Today, alongside big data architectures, this core relational concept remains vital. Every time you swipe an app to book a flight, register for a class, or check out a cart, you interact with this exact architecture. You are a user, triggering real-world business rules that cascade across a vast, invisible web of linked tables.